All right, so this is 5.1. We're back to taking notes ourselves. All right, using fundamental identities. Okay, so I'm going to give you some tips that I think are useful. All right, so this is some tips for verifying. Number one, you could try to get all of the terms into the same trig function. All right, number two, you're going to substitute formulas. Okay, so you're going to substitute things like the formulas or the identities, all of those things that we talked about in chapter 4, you're going to try. Okay, you're going to try to kind of just change things around. Number three, you could try to factor and cancel. Okay, you could try to get like common denominators. You know, you could try to FOIL, etc. Okay, so you can try just basic algebra skills. If it looks like you have two fractions and they're being added together, then you should get a common denominator and add them together. Okay, sometimes that will be helpful. All right, sometimes as a last resort, you could get into the basic building blocks. Okay, and what I mean by that is like sine and cosine. Okay. Here's the most important thing. You have to show all of your work. But not only do you have to do that, you have to do it legally. The illegal stamp comes out a lot in this unit, okay? So every time you do something illegal, you're going to see that stamp. Don't get offended. It's just a warning, like, hey, okay, I was thinking wrong here, all right? All right, so you ready to try some of this stuff? This is like what we did. There was like a couple questions in chapter 4 that we did like this, where it was like verify so that both sides matched, all right? So that's what we're going to do now. So we're just going to do some examples here. And let's just use the direction of simplify. Okay? So simplifying is a little different than verifying. Okay? So let's say we have example 1. Sine of x times cosine squared of x minus the sine of x. Alright, so when you simplify, you don't have the answer, right? It doesn't say equals something, so you don't have to make both sides match. All you have to do is take this as simple as it goes. So when you're trying to simplify, you're trying to really get everything in the same trig function. So does anyone see anything I could do here? I don't want to give it away. So does anyone see anything? Does anything stand out to you? Yeah.
Could you vector out sine of x?
You sure could. Okay, so does everyone see that has a common term there, sine of x? That's a good place to start. Okay, so let's do that. So we're going to factor out the sine of x. So we're left with cosine squared of x minus 1. Okay. Alright, so keep thinking. Did you see anything else? Ryan? This would factor to cosine of x plus 1 and cosine of x minus 1. It would, but it doesn't help us to simplify. Okay, if we were solving, that would help us. Okay, but we're just simplifying. So, yep.
Is like cosine squared of x minus 1 equal to cosine?
No. There is an identity we want to use, but that's not it. Yes?
Sine squared plus, or sine squared minus 1, or plus 1.
So sine squared minus 1 or plus
Or
1.
1 minus sine squared, yeah.
Okay, so you're thinking that cosine squared is 1 minus sine squared.
Yeah.
And I agree with you. Okay, so here's what I like to do sometimes when I'm showing this stuff to students. I'm just going to make a little thinking bubble over here, okay? So this is kind of what's going on in my mind when I see this. So I see a sine and I see a cosine, and I want them to match somehow to simplify. So I want to think about, okay, how can I change something? All right, so that's the first thing I think. The second thing I think is I have a squared term. Now, I know that there's these Pythagorean identities that use squared terms. So most likely, I'm probably going to have to introduce one of those. So what Tanner's referring to is we know that cosine squared of x plus the sine squared of x equals 1. Remember that Pythagorean identity we learned? Hopefully. Okay. If I manipulate this, isn't it true then that cosine squared of x equals 1 minus the sine squared of x? Right? That's the same thing. It's just being manipulated. Okay. Well, now, can I just take this cosine squared that I have here and replace it with this? So now I'm all in the same trig function. Okay. So I have sine of x times 1 minus sine squared of x minus 1. So I took the cosine squared and I replaced it. So now I have everything in terms of sine. Okay, so now let's keep going. So the next thing we're going to do is we're just going to simplify within the parentheses. So I'm going to have sine of x times, the ones cancel and I'm left with a negative sine squared of x. Okay. Well, what could I do now? Can I just multiply? Right? And when I do, I get negative sine cubed of x. Notice I went from having 2 trig functions within the expression to now only having 1. And I only have 1 term. So now this is simplified. Okay? So that's kind of the goal. It's going to take a little while and it's going to take a refresher. So if I were you right now, I would have your formula sheet turned over looking at that just to make it fresh in your mind. Okay? Can we move on? Yeah, Jake?
What do you use
Later on, once we get into some of those other things, some of the other formulas, when we're talking about 2 angles at the same time. Okay? All right. Let's try this one. Sine to the 4th x minus cosine to the 4th x. Okay, so you're going to kind of guide this. I don't want to give away all the stuff. So what do you think?
You break it apart into sine squared of x.
Okay, how could I do that? Yeah, I can bring in some sine squareds. I can bring in some cosine squareds too. How? It's our favorite F word. Not that one, the other one. Yes, factor. Factor is the correct answer here. Isn't this really a difference of squares? That 4th power always throws you off, right? What's sine squared times sine squared? Sine to the 4th. What's cosine squared times cosine squared? Cosine to the 4th. I just need to make the middle terms cancel. Isn't that creating that difference of perfect squares there? Okay, so this factors to sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x. Alright. Well, got to keep going. So now what? Joey?
Doesn't sine squared of x plus cosine squared of x equal 1?
It does. So this piece right here is equal to 1, right? So that means that, well, that just kind of goes away, right? So now I'm left with sine squared of x minus cosine squared of x. Now when you're simplifying, you're trying to get it down to 1 trig function. So how can I do that? Go Go back to what we were thinking before.
Do the same thing we did in the last problem?
You can do the same thing, right? We know that cosine squared is equivalent to 1 minus sine squared. So couldn't I approach it that way? Okay, so I'm going to do that. I'm going to do it like this because hopefully you'll see something else. So I'm going to replace cosine squared with 1 minus sine squared. Yes. Yeah, sure. Okay, so now when I simplify that, I end up getting 2 sine squared of x minus 1. Could I have done something else? Well, I did. I distributed. I'm talking about here. Could I go back to the step I was just on previous? Could I have approached it differently? Yeah, Jamel? I could. So I also know that because this Pythagorean identity exists, sine squared is equal to 1 minus cosine squared, isn't it? So I could have replaced sine squared. If I would have done that, then I would have had 1 minus cosine squared of x minus cosine squared of x. And that would be equal to 1 minus 2 cosine squared of x. Both of those answers are acceptable. Both of those approaches are correct. Everything is done legally and you have simplified. So either one of these answers is correct. Okay? That's kind of the issue with simplifying, is there's so many different ways to approach it. There are different answers that you can sometimes get for each problem, and it's sometimes hard to know when are you done simplifying. Okay, you're done when you've gotten it down to one trig function. There's no other identity to kind of substitute and simplify that way. Yeah.
How did you get the 2 sine squared?
So I distributed the negative. That gave me a sine squared plus a sine squared, giving me 2 sine squared.
And then did you just like, where'd you get the minus 1?
It was sine squared minus cosine squared. I kind of shoved in the minus right here. So I replaced the cosine squared with 1 minus sine squared. Right, right. Okay? Everybody okay on that example? All right, see the 2 different approaches? Either one is acceptable. Moving on. It's going to take a little while. All right. How about this one, round number 3? Secant of x times the cotangent of x. Yeah?
Let me show our work. You have to show which and then
No, so like this stuff in pink here, that's kind of why I was just calling it like this thinking column. It's really not necessary in your work, but all of the steps that I have shown are necessary, okay? So none of this pink stuff, okay? All right, well, how about this one? This one's a little different. Think about what you could do here. Any ideas? Noah's got one. Anyone else see it at all? Anyone see it yet? Okay, Noah, you're up.
The secant simplifies to 1 over cosine, and cotangent is cosine over sine, and then cosine cancel.
Very good. Okay, so here's the deal. Remember, one of those tips that I gave you was you can try to get it into the basic building blocks. If it doesn't look like there's any type of algebra step that you could take, such as like multiplying or factoring or things like that, then you should try to go back to those basic building blocks, okay? So Noah's right. Secant is 1 over cosine, and cotangent is the cosine over sine, okay? And now we have that canceling going on, giving us 1 over sine. Now, 1 over sine is not our final answer. Yes, it is one trig identity, but what is true about 1 over sine? It's cosecant. It's a reciprocal identity. So, at the very end, you always want to check for that, okay? Can you make anything more simpler? And 1 over sine is not as simple as cosecant. So, cosecant is our answer. Okay? Alright, this one you're going to get. So, cosecant of alpha. Now, don't freak out, okay? They're going to start introducing different symbols for us to use, and it's okay, all right? Don't freak out. It's all right. So we're going to have cosecant times the cosine of alpha over cotangent of alpha. All right, so what are your thoughts here? It's going to take a minute, and it's okay. Just think about what you could do. Okay, we've got a couple ideas out there. Go with the idea of what we did in number 3. Kelly, what do you think?
Gives you like, like cosine over 1, and then you can like times it by like tangent, which is like
Yeah.
sine over cosine.
Yeah. Okay, just pause there for 1 second. You're absolutely right. But pause. I want to just talk about the fact that what you're talking about doing is basically splitting this fraction, right? And you're totally allowed to do that. So let's just write that out so we can all see what's going on here. So I have the cosecant of alpha times the cosine times 1 over cotangent if I was to split those, right? Now, Kelly, you said that 1 over cotangent is the same as tangent, and you're absolutely right because of that reciprocal idea, okay? So now I'm going to change this to the cosecant times the times the cosine times the tangent. Does everyone see how that happened? Okay? All right, so Kelly, now you can keep going. Now what do I do?
Then you just do cosine over 1 times sine over cosine. So it'll just be like just cancel.
So you want to change this tangent to sine over cosine.
Yeah.
While I'm at it, can I change this cosecant too?
Yeah.
Okay, so I'm going to do 1 over sine times cosine over 1 times sine over cosine. So now remember, when you multiply fractions, everything in the numerator gets multiplied, everything in the denominator gets multiplied. So this is all like one numerator over one denominator. So what happens here? Cosines cancel, the sines cancel, and we're left with 1. Pretty cool. Okay, now I would say the only step you really don't have to show me would be like this first one. If you went right to here, I would be okay. Okay, the more work you show, the better, because it allows me to see where you were thinking, and if you were thinking correctly, and I can give you some partial points, or if from the very beginning you were illegal. Okay, so it kind of helps me to see that. So show your work. Are there any questions on number 4? Okay, 5. This one looks different. Arwa?
Are you going to like distribute the cosine and sine and then like cosine negative? So you get cosine negative cosine of x over negative sine of x, and then
You can't pull those negatives out. You can't. You can apply an idea and change it, but you can't do that. Joey?
cosine over sine is cotangent.
Okay, so right now we're kind of thinking like maybe cotangent might come into play. And I do agree with you, but we can't bring it in yet. The problem is I have these negative x's. Does anybody see anything on the formula sheet where you might see a negative x? So you might have to apply something. Alyssa? Yes, the even and odd idea. Okay? Which functions are even? Cosine and secant. And what does it mean for them to be even? It means that they stay the same. So whether you put in a negative x or you put in a positive x, it's exactly the same. So isn't this numerator exactly the same as a cosine of x? Now I no longer have a negative x, so that's no worry. Okay, so now I got to make the same thing happen in the denominator. Now, even and odd functions are still going to come into play. Sine is an odd function. What does that mean? It means that it changes signs. So that means that this is really like a negative sine of x. And now, Joey, you can apply cotangent because cosine over sine is cotangent, so I have a negative cotangent of x. Isn't this fun? I mean, it really is kind of fun. Okay? It kind of. Okay, I see some people like, oh, maybe a little bit. Okay, I'll take it. I will take it. All right, moving on. You ready to try one? You want to try one on your own? Okay, so try one on your own and then we'll talk about it. This is beta. It's like a big B with a tail, okay? So we have the cosine of beta times the secant of beta minus cosine beta. Anybody want to volunteer their first step? Don't be scared. Jake?
Okay, so I changed secant into 1 over cosine of beta.
I would have also done that. Now, if you didn't, that doesn't mean you're wrong, so don't start erasing yet, okay? Just keep watching, and maybe it'll all work out in the end, okay? You don't have to do this first. How many people did that? Okay, good. Because then, after you do that, what should you do with that cosine outside? Distribute. It looks like you should multiply. You should multiply. You could have done that at the beginning, okay? So when we do that, the cosines cancel here, leaving us with 1. And here we get a minus cosine squared of beta. I hope you didn't stop there. Did you? Okay, you didn't stop there because there is a formula going on here. Isn't there the Pythagorean identity happening here? 1 minus cosine squared is equal to what? Sine squared, and that's where you should go. So this is your answer. Sine squared of beta. Okay. How many people got to here and stopped? Okay, it's okay to admit it. Okay, so what you want to do at the very end is look to see if you can use any other formula. All right, go to your formula sheet. Is there an identity? Is there a reciprocal? Something like that. Okay, so always check for that. Yes?
Wait, so like I tried to simplify the parentheses without multiplying. So like I got 1 minus cosine squared of beta over cosine, so then I got tangent.
Yep.
And then when I multiply cosine times tangent.
Yep, cosines cancel, leaving you a sine. That's exactly right. Okay, so she worked in the middle, or worked in the parentheses to begin with, and that's totally fine. There are multiple approaches to these, all right? Most of the time we'll end up in the same place. Sometimes, like in a case like example 2, there's 2 scenarios going, and that's okay too, all right? All right, this is going to be the last one for the simplifying part. So let's try this one. It's going to look very different, okay? So don't get scared. Okay, it's called sigma, all right? It's like a diving fish. All right, so first of all, you got to get past the symbol, right? And if you don't like it, then think about it like, theta or x, all right? So get past it. Now you got to go probably to the formula sheet because this looks incredibly weird, right?
I have a question.
Sure.
So, like, if we were just, like, doing our work, could we, like, change it to x, but then...
You could if you really needed to. Yeah, okay? So I'm going to do a little thinking here. All right, and you might want to make these on your paper just while we're kind of talking through some of this stuff. If you feel like any of this kind of was, oh, okay, yeah, that's how you approach it. You might want to make a note to yourself when you're trying this later on. So I don't know about you, but this looks very weird to me. Okay, it looks different, right, than it did before. Any thoughts, Genevieve?
Cosine of pi over 2 minus
Sigma.
is equal to sine.
Yeah, and isn't that, if you go to your formula sheet, you guys, isn't that your cofunction identity, right? Those cofunctions kept hanging us up last unit. They're going to keep doing this, so they just come up at random, okay? And you got to recognize that that's a cofunction, and you're absolutely right. The cosine of pi over 2 minus theta, or whatever symbol you want to insert there, is sine. So this is the same as, whoopsie, I kind of switched colors here. Sine of sigma over what? Cosine. Okay, this is easier to work with. All right, well, what's sine over cosine? Tangent, and that's where we'll end with that one. Okay, it's like a puzzle. You got to keep on plugging in those pieces, keep manipulating until you get there. If you don't know your formulas, this is going to be incredibly difficult. All right, so please take the time to look those over tonight. All right, so now we're going to shift gears and we're going to actually verify. Okay, so this is what you were doing in chapter 4. So we're going to keep on going with our examples, but now we're going to change the directions to verify. So verify and simplify are two different things. Okay, let's make some steps. So the steps to verifying, we're still going to use all of those same tips that we had before, but now we have actually rules to follow. So now there is a set way we have to do this. Step 1, you have to choose only one side to work on. And if you remember back in the last chapter, I always told you try to work on the more complicated side, right? Because there's more to do. So you choose the more complicated side. Okay, step 2, you're going to use legal moves to make both sides match. Okay, yes?
Are you going to show us examples of illegal moves?
Yes, I will give you some illegal. I can talk about some illegal moves. I think I have. Remember that Can You Find My Mistake worksheet we did a while back? I want to say I made one for this, like with illegal moves on it. Yeah, so it's coming. All right, so we're just gonna do a couple of these. So I guess I don't know what you want to call this. If you want to call it 8 or 1, I don't know. I'm kind of switch things up today. All right, let's go with the sine of theta over 1 plus the cosine of theta plus the cosine of theta over the sine of theta equals cosecant of theta. Okay. So you can tell the difference between a simplifying and a verifying because there's an equal sign. It's an equation, all right? So we're going to choose the side. What side do you want to work on? The left or the right? Definitely, okay? So we're going to work on the left. It would be very hard to take the right side and make it look like this, okay? That'd be very difficult, if not impossible, okay? So we're going to choose the more complicated side, and now we're going to think. So we got to think. I'm just going to do this little thinking column over here. All right, so what are you thinking here? Ryan?
The sines cancel out, so the cosines.
Whoa, 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 whoa.
Or just the sines cancel?
These, you want to cancel these? Can we do that? Illegal. Super, super illegal. If it was being multiplied together, we could do that. Okay, but not adding. Okay, so make yourself a note. No canceling. Arwa.
One plus the cotangent is equal to sine, so then the sine of theta over sine of theta is 1.
So you want to change this one to cotangent?
No, the 1 plus the cosine on the bottom. Yeah, isn't that sine?
No. 1 minus cosine squared is sine squared. Okay, you can't like take the square root of that. It doesn't apply. Okay? All right, good try. Sam?
I'm gonna, like, times the left one by sine and the right one by 1 plus cosine, so you get that.
Yeah, and why would you want to do that? You're absolutely right. Why would you want to do that? Yeah, there's two fractions being added together. If I told you 1/2 plus 1/3, what would you do? Get a common denominator. Why is this any different? It's not, right? Don't let those trig functions intimidate you. Go back to what you know about algebra, right? If you are going to add two fractions, you have to have a common denominator. So that's where we have to go with this. Okay, so we get a common denominator. So to do that, we're going to multiply this side by the sine of theta, and this by 1 plus cosine of theta. Okay, now remember from before, every single time you're verifying, every step has to say equals cosecant until we get to the very end where it says cosecant equals cosecant. So now I have sine squared of theta over sine of theta times 1 plus cosine theta, plus, I'm going to distribute this cosine, so cosine of theta plus cosine squared of theta. Are you with me there? What just happened? All I did was distribute my numerator, and then I combined it into one fraction. Okay, what do you see now? What's going on here? What's sine squared plus cosine squared? Yeah. So sine squared plus cosine squared is 1. So sine squared plus cosine squared is here in our numerator. So I can now change this to 1 plus the cosine of theta over sine of theta times 1 plus the cosine of theta equals cosecant of theta. Almost there. Yeah, great.
So would the top and 1 plus cosine cancel out with 1 plus?
Yes, now these are allowed to cancel out because they're being multiplied together. So this cancels this. I'm left with 1 over the sine of theta equals the cosecant of theta, and I am one step away from being done. What's 1 over sine? Cosecant. So now both sides match. You have to show me that. I know it seems like a silly step, but you got to show me that last step with them matching. Okay? And you're done. You're verified. That's it. You already have the answer. You just have to figure out a way to get to it. Now listen to me. I have been doing this a long time. Okay? You're not going to trick me along the way. All right? So you know the answer. I know the answer. You're not going to fake your way in the middle to get to the end. Okay? I'm pretty smart. I can figure it out. All right? So just a warning, be legal. Okay? All right, one more of these. You ready? All right. We'll call this, I guess I'm going with number 2. I have the natural log of the absolute value of 1 plus the cosine of theta, plus the natural log of 1 minus the cosine of theta equals 2 natural log sine of theta. Well, this isn't too intimidating. Okay, number 2, this is example 2, but you can do it. You and your partner are going to talk about how. Those are absolute values, yeah.
One multiply is right here. I think the addition there makes that. But good try. It was in 10. That's okay.
Unless he wants one.
What is 1 plus cosine? Yes, you can only work on the side, right? Because I was thinking, this is like this, and sine squared technically. Natural log sine squared. Or is that mean just 2 of those? Yeah. Well, whatever's more complicated. Somehow, it's got to be.
All right, you guys. Were you thinking that you should work on the left?
So these two have
Did you at least start there? We all okay. So that's very good. Did you start applying the rules of logs? So when you have 2 logs being added together, you can do what to them? Condense them into multiplication. Now, if you forgot about that, you should probably go back and redo the rules of logs, because this is going to come up a lot. Logs keep coming up. Okay? So just go back to those properties of logarithms, how to condense, how to expand. I'm sure the lesson is on the YouTube channel. Okay? Okay, so now what did you do? Did you multiply those? Excellent. Do you have equals to natural log of sine of theta in every step? Okay, so now we have natural log of 1 minus cosine squared of theta equals to natural log of sine of theta. All right. Now where'd you go? This is equal to sine squared, isn't it? It's an identity. So now you change natural log to sine squared of theta, and we're so close. What can you do with sine squared to make it look like 2 natural log of sine? Pull the exponent out. Isn't that a property of logs? If you have an exponent, you just pull it out front. You're done. This was actually an easier one, I think, than the last one. What about you? Easier or harder? No comment. Okay. Yeah. No, so the reason why there's an absolute value there is, remember that the natural log and log have a domain of 0 to infinity. So it's telling you this has to be positive, whatever it is. Okay? Yeah.
So we're only allowed to work on one side?
You are only allowed to work on one side. So if you work on this side in the middle of this, it's all wrong. Okay? It's so important. And that is the #1 mistake students make with verifying, is it seems so easy. You could just move it over to the other side and be done. You're not allowed to do that. Okay? Remember back to geometry when you're having to prove things and show your thinking? This is the same idea.